Alright, so first of all, I would like to apologize for not being in class today. I had something planned before I knew I was going to take over Mrs. Fosspour's maternity leave. So, even though you have a different sub there today, we are still going to do a lesson. We're going to start our chapter 14, which is over geometry, and specifically area. And we're also going to work on section 1. So section 1 is talking about the area of parallelograms. Parallelograms. Long word to spell. Alright, so that's what our chapter is going to be, or our section is going to be about parallelograms in general, but our chapter is going to be, is going to be the area of different shapes. Alright, so let's just start with what area is. So area is the space inside shapes. Ooh, I'm sorry, misspelled that. Alright, so that's what area is. Area is the space inside any shape that is given to you. So as we go through this chapter, we're going to be referring back to different formulas that we can find area of different shapes when we're just given the length of the sides. Now, parallelogram. We probably learned parallelogram when we were 5th grade, 4th grade. I know 3rd grade definitely goes over them. But let's review what a parallelogram is. A parallelogram is a type of parallelogram is a type of quadrilateral that resembles a rectangle. So I'm going to draw one real fast for you. It's not going to be perfect. It's a parallelogram shape that resembles a rectangle. So I like to call them a lazy rectangle, because it kind of looks like to me that the rectangle is just slouching over, right? So if we really think about it, there's your rectangle and it just kind of goes whoop, right on over. So it's kind of like a slouching lazy rectangle. So with that being said, we're going to learn how to do the area. So with the area, we are actually going to take our parallelograms and decompose or break apart the shapes to look like a rectangle. Alright, so with that, scroll down to some of my parallelograms down here. They're not perfect by any means, but they're going to have to work for today. So, let's look at our first parallelogram over here. Our first one. Alright? So we're going to learn how to decompose it to be a shape that we're very familiar with, right? So what we're going to have to do is we're going to start up at the point. I like to start up at the left point, and we're just going to draw a straight dotted line straight down. And that little box I just made is called a perpendicular box. So I know that this dotted line is perpendicular to the solid baseline we have. That makes a 90-degree angle. Right? So I'm going to take this area, right? This right here, and we're going to take it and we're going to replace it over here. So I'm going to just redraw that triangle I just made right here. So now, if we take off that side, we have a rectangle. Okay? As we follow along through that, let's go into the next one. Our area does not change from parallelogram, even though we switched how it looks. The parts are still the same. We're just moving them to make it more familiar. So we all know how to find the area of a rectangle. So the area of a rectangle is length times width, right? That is the area for a rectangle. Okay, so with that, we use different words for our parallelograms. We're going to call the bottom line a base. Alright, and then that line that we make straight down, instead of our width, it's going to be called the height. So you'll see these referenced as B as for base and H for height. So when we take this side over, right, it's going to move all the way over here. We're going to draw it on. So we now have a rectangle. So with that being said, the area of a parallelogram is very similar to the area of a rectangle. The area, so A equals area of a parallelogram is just base times height. Very similar to length times width, we just use different words for them. Right? So the area of a parallelogram. So we just broke apart our parallelogram up here, moved the triangle from one of the sides. We moved it from the left side. You can also move it from the right side. We moved it over to the opposite side and created a rectangle to really see the length and the width, right? With that being said, we are now going to look at how to solve. We're going to look at how to solve for those rectangles if we're given the sides. So on our next sheet of paper, we're going to try it. So again, my parallelograms aren't perfect, but that's okay. Yours will be. So let's look at problem 1 up here. Right, so this 8 is actually my height, and the 9 is the length of the base. So if I'm going to write here, I'm going to put height equals 8 and the base equals 9. I can also decompose that, so I already have my line drawn here, and I can move it over here to really resemble a rectangle. So skin is just, if I do that, this side is gone, and it's just length times width. But if we write it in our form, so area, A equals area times our base times height. And we know that 9 times 8 is 72. So my area is 72 for this specific parallelogram. Alright? Let's go to the next one. Again, my area is going to equal my base. So sometimes your base is going to be up top, but that's the same length as the bottom line going to be. So still, it's my base times my height. And we know that 5 times 2 is 10. So that is the area of the second parallelogram. Let's go down to the third parallelogram. This is going to be number 3. Alright, at the bottom. Okay. Every once in a while, your height is going to be on the outside. Right here. Your height. It means the exact same thing, but what they did is they took this side and they just replaced it over here, right? Again, it's not perfect, so ignore that line. It should be a little more straighter. Something like that. Okay? So what we're going to do is, again, we're going to separate area equals, what is our base? Our base is 6. Base times, and our height is going to be 3. So we know that 6 times 3 is 18. So that is our area. Now, you also might have to solve for the height or the base. And we're going to set it up almost exactly the same as we did here. So if we have a parallelogram, we can draw them real fast. And I'll say my area is going to equal 32, and my base is 8. We need to find the height. That's h, right? So what we're going to do is we're going to set up with, our formula's area is base times height. We're going to just substitute what we know for that formula. We know area is 32, and we know our base, which is b, is 8. We're going to keep our h. So to get rid of this multiplication problem, we're going to divide by 8 on both sides and get 4 equals h. So my height is h. You do the exact same thing if you're looking for your base. So let's say that we know that the base or the height is 4, right? We know this is 4, but we're still concerned about the base. You can just go set our formula back up again. The 32 equals b times 4. You just divide by 4, and you're going to get 8 equals b. So you know our base is that. And then once you plug it back into the top, 4 times 8 is 32. It matches the area that we already have. Okay? So that is all we're going to do for our chapter 14, section 1. When I come back, we're going to work on more area for like triangles, trapezoids, and things like that. What I need you to do now is to make sure that you go into ClassKick, finish the notes, so I can look at them, make sure that you were listening and paying attention to this video. And then you also need to go onto Math IXL, which is, your Math IXL is going to be IXL is A.2 under 7th grade. It's very important, under 7th grade, for 10 minutes or 90%. Right? So that is your homework. If you don't finish this video in class, that is also your homework to make sure your notes are turned in by the next class period. Alright, and I will see you guys on Thursday. Thank you.